Back. I am now in your notes on the top of page 12 here. Page 12, dealing with inverse functions. Now, we're going to come back to this definition of inverse functions quick, but what I want to do is do these warm-up exercises first, because if you can do these warm-up exercises, this will be pretty quick for you. This goes back to chapter 1 when we were dealing with solving for y. Here, to solve for y, you have to divide by 3 because it's being multiplied by 3. So you get y equals 2x. Here, to get the y by itself, it's being added by 3x, or this is a plus in front of here, technically. So we need to subtract this to get it to the other side. So we got to subtract 3x. So we get y equals, and all I'm going to do is I'm just going to write this negative 3x. I'm going to write that first. So I'm going to go negative 3x plus 6 because that's positive 6. And this last one, you got to subtract 2x first, so you get 6y equals. Again, I'm going to write the 2x first. And since that's negative and this 6 is positive, it's negative 2x plus 6. And then divide by 6, making sure that when I divide, I put both of these over 6, not just one of them. I got to put them all over 6. So negative 2 over 6 is negative 1/3 x plus 6 over 6 is 1. So if you can solve for x, or excuse me, solve for y like we did in chapter 1, this will be fairly quick. Because all we're going to do is, when looking at inverse functions, an inverse function is simply a relation that maps output values of an original relation back to the original input values. This means that the domain or the x values and the range of the y values, all they do is they switch. So if we take a look at this example down here where it says discovering inverses, here's our given problem. Notice in step 1, the only thing that they did is they took this x and put it over here, and they took the y and put it over here. Otherwise, it's the exact same thing. You switch the x and y. Then, they added 5 to both sides. They divided by 3, split it up to get this as the inverse. So given this original problem here, here's your given, this is what the inverse is. This can kind of be summarized in 2 quick steps. By using the example above, you can write some sentences here if you wish. But I'm going to go step 1 here. Step 1, the simple thing in the given is just to flip your variables. You're going to take the x and put it where y was, and take the y and put it where x was. Then step 2 is once you have it flipped, you resolve your new equation. Resolve the new equation where most of the time for us, it's going to be solving for y. Most of the time. You'll get in some higher level math where it won't be just solving for y, but for us, it's going to be solving for y. So example 1 here. All I'm going to do to find the inverse of this function, let me get some of this green out of the way, is I'm going to flip-flop these variables. So now it's x equals 3y plus 1. Not plus 1, minus 1. And I am going to solve for this y. I'm going to try to isolate this y by, this is where I get my plus 1. X plus 1 equals 3y. Divide everything by 3. So x, when I take this x over 3, 1 over 3, and 3 over 3, this will cancel. X over 3 I'm going to write as 1/3 x plus 1/3. And I'm going to put the y equals out front. Y equals 1/3 x plus 1/3. That is a very quick way to find the inverse of this relation right here. So what I want you to do is I want you to try these 3 right here. I will put the answers online, but I'm going to move on to the second concept, which is checking to see if it's an inverse. But I do want you to try these first. So go ahead and pause or stop and come back to this video, but I want you to try the try-its on the bottom of page 12 first. All right, moving on. If they give you 2 functions, like example 1 right here, they give you an f and they give you a g, there is a very quick way to tell, are they inverses, yes or no? And the good news for you is all these directions will say verify. So actually it's telling you that the answer is yes, they are an inverse. And here's how you tell if they are or not. Go back to a previous video dealing with composite functions. This was the fog, f of g of x, and this was the goth, g of f of x. All you have to do is find the composite of this first one, given the second one, and make sure that that simplifies down to be just plain x. And do the same thing with the goth, with the g of f of x. You simplify that down and make sure that that gets to be x. Because if it is, then the function g is denoted by f of -1, and that's read as f inverse. if you look on your calculator, you will see several buttons that have this -1 up here. That just simply means inverse. So here we go. Switch colors here from pukey green. I'm going to verify that these two functions right here in example 1 are indeed inverses. How I do that is I got to find the fog and I got to find the goff. I got to plug f of g of x and g of f of x into a composite function and make sure that at the very end I should get x. I should get x. If I didn't, then I did something incorrectly. So let's start with the f. I'm going to start here and I'm going to start writing 1/2. I see an x right there, so I got to make sure that I put this in parentheses, 4x. And then I still have my -2. Distribute that in there, you will get an x plus 2 minus 2, which does in fact equal, make our equal sign really big here, equals x. So this one's good. The top one, this one's a check. Now I got to check the bottom one. Going the other way around, I write a 2. I plug in this everywhere I see an x in parentheses, so I go 1/2 x minus 2 plus 4. Distribute this in here and you will get an x, it looks like -4 plus 4, which does in fact equal x. So since they are both good, they both equal x, you have successfully verified that yes, these are inverses. So what I'm going to do now is I'm going to put the answers to these two triads again. I want you to pause and stop and go again. I want you to try this triad and check with the answers online before moving on to the inverse of a power function. Alright, down at the bottom here. Inverse of a power function. Last example I'm going to do, then you're going to have these triads. What I'm going to do is this f of x is the same thing as y. So I'm going to rewrite this as y equals 1/4 x squared. Oh boy, I have to sneeze. Excuse me. To find the inverse here of this power function, I'm going to flip these variables. So I end up with x equals 1/4 y squared. To solve for y, I have to take care of this 1/4 first. I'm going to multiply by 4, so I get 4x equals y squared. And now we get to this fun part of taking the square root. Square root, square root. So I end up with y equals the square root of 4, which is 2, and we have ourselves a root x. This would be the inverse, or if we were writing it in the correct notation, since they gave us this an f of x, I have to rewrite this as f -1 of x equals 2 square root of x. This is the inverse of this function up here. So the only thing we added new is you might have to do a square root in here every once in a while. Like this one here, you're going to have to do a 5th root. This one here, you're going to have to do a square root, a 3rd root. Watch your pluses and minuses. Right here, this one you will not need a plus and minus. This one you will not need a plus and minus, but this one you will. We will discuss more on the plus or minus in class, but give those a shot and see what you got.